Right, let's look at Pythagoras Theorem. It was very novel to introduce the terminology opposite and adjacent and then set up Pythagoras formula as hypotenuse squared is opposite squared plus adjacent squared, which means that there's less likelihood of the common mistake made where you're asked to find one of the shorter sides, and quite often students will just add the other two numbers squared. But I have a problem with this here. You cannot talk about opposite and adjacent unless you have reference to an angle. So if you're given a right angle triangle and you're given this as 5 and this is 3 and this is the hypotenuse, you cannot label opposite and adjacent unless you have reference to an angle. So you're introducing something that is unnecessary. When it comes to trigonometry, yes, it's important because then you've got the angle. Furthermore, don't say, well, it doesn't matter which one you call opposite and adjacent. So, in other words, here we are. Don't say, well, it doesn't matter, call either of them opposite or adjacent. In this particular example, it's not a problem. But that's going to confuse them when they come to trigonometry. Why, in Pythagoras, could you just label any one opposite adjacent? And now when it's in trigonometry, we have to be very careful. So I would avoid that completely, the opposite and adjacent. I would simply use something like a squared hypotenuse is a squared plus b squared, where those are the shorter sides. But before you even start this here, I would recommend that you do this on a piece of graph paper. So you would draw on graph paper a triangle 4 units, 3 units, and then the hypotenuse. You would then draw the square, and then this is on your graph paper, and you highlight these lines, and you can show that the area here is 9 units squared, and here the area is 16. Now when you come to the hypotenuse, you do the same thing. Use your horizontal and vertical lines, right? But over here, you're going to have exact half triangles, which you add up as one, and you can show that this area is 25. So you're giving a very concrete explanation of why, if you square this side and square that side, it's equal, and add them, it's equal to the square on the hypotenuse. Then when you come to just using the formula, the one thing to stress is that they always write down the formula starting with the hypotenuse. And if they do that, they are less likely to make the common mistake I was talking about. So let's look at an example, what I mean by the common mistake. So you're given this as 13, and you're given this as 12, and you're asked to find x. Now, many students will say, oh yes, I know Pythagoras Theorem, x squared is 13 squared plus 12 squared, which of course is wrong. That is why I say, tell them, stress, start with the hypotenuse as the subject of the equation, all on its own, is equal to the sum of 12 squared plus x squared. And then they rearrange, and hopefully they will rearrange it correctly to get 13 squared minus 12 squared. And again, I would encourage them to always start off by writing out that formula and then substituting into it.